Welcome to section 513. We're going to be talking about solving systems of equations. Now, there's multiple ways to solve systems. We could use substitution, elimination, and we're also going to talk about some more difficult ones with quadratics and such. Now, looking at problem number one, they're both equal to y. So if they're both equal to the same thing, we can set them equal to each other using substitution. So what we have, negative 3x plus 5 equals negative 3x minus 1. So what we would do is if we add 3x to both sides, now the variables cancel. We're left with 5 equals negative 1. 5 never equals negative. What we get is that false statement, something that's not true. So what we have here is a system with no solutions. Remember, when we're looking at solving systems, we're finding out where the graphs intersect. What this is telling us that these graphs never intersect. That's why there's no solution. There's no common point on both. Looking at problem number 2, once again, they're both equal to y. Set them equal to each other. So 1/2 x squared plus 1 equals 2x minus 1. Now what we could do is we could get rid of the fraction by multiplying each term by 2. Once, twice, 3 times, 4 times. Which gives us the equation x squared plus 2 equals 4x minus 2. All right, so now it's a quadratic. Let's get this equal to 0. Subtract 4x from both sides and add 2 to both sides. X squared minus 4x plus 4 equals 0. And this we can factor. What we get is x minus 2 times x minus 2 equals 0, or x minus 2 squared equals 0. So to solve, take the square root of both sides. X minus 2 equals 0. So we get x equals 2. Now, that's our value for x. We still need to find out what y equals. Now, it doesn't matter which equation we substitute into. Let's use the bottom one because it looks a little bit easier to work with. Y equals 2 times 2 minus 1. So 4 minus 1, y equals 3. So our solution is actually at 2, 3. That's the point of intersection. That's where these two graphs intersect, at that one point. Problem number 3. Now, the one equation is equal to y, but the other equation is equal to y squared. Now, x equals y squared. So in the second equation, wherever we see x, we can put y squared in its location. Substitution. So we get y equals, instead of writing x, we're going to substitute the y squared. Minus 2. It's a quadratic. In order to solve, we have to get it equal to 0. So I'm going to subtract y from both sides. So 0 equals y squared minus y minus 2. And we can factor this. Y and y. Multiply to negative 2 and add to negative 1, we get minus 2. And then plus 1. So set the factors equal to 0. Y minus 2 equals 0. Y plus 1 equals 0. So our solutions for y are y equals 2 and y equals negative 1. Now we still need to find out what x is. Now we can find x using either of the equations. I'm going to use the top equation because it looks a little bit easier to work with because it's already x equals y squared. So x equals, now we have to use both values for y separately. X equals 2 squared, so x equals 4. So one of the points of intersection is 4, 2. And when y equals -1, x equals -1 squared, so x equals 1. So our other point of intersection would be 1, -1. There's our 2 points of intersection. There's our 2 points of intersection. Problem number 4. See how the bottom equation solved for y? This is a good substitution problem. Wherever I see y in the top equation, I'm going to put 2x minus 5. I'm going to substitute. So we get 4x minus 2 times the quantity of. Now instead of writing y, 2x minus 5. And that equals 10. 4x, distribute the -2 minus 4x plus 10 equals 10. When we combine our like terms, we get 10 equals 10. The variables are gone, and that's a true statement. What this means is that we have infinitely many solutions. Now, infinitely many solutions means we have an infinite number of points of intersection. If we graph these 2 lines, they're stacked right on top of each other. Every single point on that line is a point of intersection. So if you get a false statement, there are no solutions. If you get a true statement, there are infinitely many solutions. Let's try a few more. Now, there's a couple different ways to go about problem number 5. Now, x squared plus y squared equals 25. That's actually a circle. And y equals x squared minus 13. That's a parabola. So what we could do is, to make our substitution a little bit easier, I'm going to solve the bottom equation for x squared. So I'm going to add 13 to both sides. X squared equals y plus 13. So wherever I see x squared, I can substitute y plus 13. So it's going to be, instead of x squared, y plus 13 plus y squared equals 25. So that gives me y squared plus y plus 13 equals 25. It's a quadratic, get it equal to 0. Subtract 25 from both sides. Y squared plus y minus 12 equals 0. And we can factor this. So what we get is y and y. To multiply to -12 and add to 1, it's going to be plus 4 and a minus 3. So set each factor equals 0. Y plus 4 equals 0. And y minus 3 equals 0. So y equals -4 and y equals positive 3. Now, we need to find out what x equals. So we can use either one of those original equations. It doesn't matter which one. Looking at it, there's really no benefit to either one. Let's just use the bottom one. So we're going to use -4 first. So -4 equals x squared minus 13. Add 13 to both sides. 9 equals x squared. Take the square root of both sides. X equals not just 3, but positive and -3. So what that does is that gives us the solution of our y value was -4. But our x values, we got a positive 3 and a -3. Now we also have to see what happens when y equals 3. So once again, -4 equals, not -4, 3 equals x squared minus 13. Add 13 to both sides. 16 equals x squared. Take the square root of both sides. X equals not just 4, but positive and -4. So we have two solutions when y is 3. We have a positive 4, 3 and a negative 4, 3. What's happening here is the graphs are intersecting 4 times. Let's go to the next page. Number 6. Same thing. I'm going to isolate the x squared, so I'm going to subtract 5 from both sides. So I get x squared equals y minus 5. So in the top equation, instead of x squared, y minus 5 plus y squared equals 25. I can see it's a quadratic. I'm going to subtract 25 from both sides. When I write in standard form, y squared plus y minus 30 equals 0. We can factor this. Y and y. Now to multiply to negative 30 and add to 1, that's going to be a positive 6 and a negative 5. Y plus 6 equals 0. Y minus 5 equals 0. So y equals negative 6 and y equals 5. We need to find our solutions. So now I can use this rewritten equation here. X squared equals. Now let's find out what happens when y is negative 6. Negative 6 minus 5. So x squared equals negative 11. And when we take the square root of both sides, we get x equals plus or minus I times the square root of 11. I is an imaginary number. That's not going to be on our regular coordinate plane. So we're not going to include that imaginary. We're just going to include the real. So we're not going to worry about negative 6 because it gives us an imaginary solution, a solution on our, not our coordinate plane, but on our imaginary plane. And now when y is 5. So x squared equals 5 minus 5. X squared equals 0, so x equals 0. So our only solution is 0, 5. And if you were to graph this, you would see that the graphs only intersect at one point because the other point of intersection is not on the real coordinate plane, but the imaginary plane. Problem number 7. Once again, get x squared by itself, so we add 5 to both sides. So you get x squared equals y plus 5. So x squared, y plus 5, plus y squared equals 25. It's a quadratic, get it equals 0, subtract 25 from both sides. Y squared plus y minus 20 equals 0. So when you factor y and y, to get that negative 20 to add to 1, positive 5, negative 4. So y plus 5 equals 0, y minus 4 equals 0. You get y equals negative 5 and y equals positive 4. You can use that bottom equation again. X squared equals negative 5 plus 5. X squared equals 0. So x equals 0. So a solution we have is at 0, negative 5. Let's see what happens when y is 4. So it's going to be x squared equals 4 plus 5. X squared equals 9. Take the square root of both sides, and don't forget you get x equals not just 3, but positive and negative 3. So our solution there would be at 3, 4, and at negative 3, 4. There's our 3 solutions. So if you were to graph these, you'd see 3 points of intersections. All right, last couple problems. We're just going to write the equation and not solve. So your math class wants to collect money for a field trip, selling 2 types of candies. The Chocolate Lovers is $4.25 and has 5 truffles and 2 caramel turtles. The Combusting Caramels bag is $3.50 for 8 caramel truffles and 2 chocolate truffles. So how much does each chocolate and each caramel cost? So those are our variables. X is the cost of a chocolate. truffle? And y is the cost of a caramel turtle. So now our first type, the one that's 425, the chocolate lovers. Now what we have here is we have 5 of the chocolate truffles. So we have, the cost would be 5 times x. Plus, for the caramel, we have 2 of them, so 2 times the cost, 2y equals 425. There's our first equation. Now our second equation, the one where it's $3.50 for the combusting caramels bag, we have 8 caramel. So we have the 8y. And we have 2 chocolates, so there's our 2x. There's our system we need to solve. Problem number 9. Now, looking at these job offers, we're not going to solve this, we're just going to kind of write it. Job A. You get a starting salary, so our initial cost, $52,000. So our salary, Y, equals $52,000 plus an annual increase of $3,000, so plus 3,000x. So our variables, Y is our salary, and X is the number of years. So we'd be able to determine how much we'd be making each year if we followed that pattern. Now, for the second offer, it's got a $36,000 starting salary, but an 11% annual raise. So this is a geometric for this one. So what would be Y equals 36,000, and it's growth, so it's 1 plus the rate of 0.11 raised to the x power. So our second equation with Y equals 36,000 times 1.11 raised to the power of x. There's the 2 equations we would be using. Okay, thank you, and I will see you in the next video.